Right, it's getting late now, so we'll try and get through this section fairly quickly. I think this is a very important section, dating. How old is life on Earth? The evolutionists need it to be as long as possible. That's why some of the folks yesterday who are enamoured with the theory wanting to push life back to, 3,500 million years ago. But how can we know? What's the best data? There's a huge conflict here. You go to just about any national park and you'll see a mural up and it'll have, this particular rock formation was formed 450 million years ago or 2 million years ago. And all our textbooks are full of, is that right? Oh, cool. Yeah. Okay. So we know that the textbooks make these assertions through. And indeed, if you say that you believe that the Earth is only 6,000 years old, which I do, I believe it's got to be somewhere around about that time, then they look at you as if you're some kind of nut. How can you believe that? Are you intellectually sort of retarded? So it's not, and it's unbelievable to them because this is so much inculcated into our education system today. One of the important things that we need to ask people is, how do you know? Right? So, how do I know it's raining outside? Well, I can hear a sound and you've told me that it's raining. But really the only way that I could really know that it was raining is I have to have confidence that your observation's fairly good, or go out there and then I can experience it by myself. And then I have to discount the fact that a burst hydrant isn't in the street next door and spraying over the top here or whatever, okay? So we need to look at, how do we know? And am I in a state of mind where I'm not being influenced by something else? So, how do we know? And I'm sure you've all had instances where even, you've thought that something was happening, but in actual fact, your senses were playing tricks on you. So how can we know? What is the best data? And this is a question that comes up. Somebody says, well, this is 450 million years old. How do you know? Oh, well, the geologists dated that. Well, how did they date it? Well, they dated it with radiometric methods. Have those methods been validated? Of course they have, they'll say. But have they? Have they really? That's what we're going to have a look at. So let's have a look now at how radiometric dating works. Because this is one of the main arguments that is used against us in terms of some sort of scientific argument. So we're going to have a basic lesson here in chemistry. Some of you will remember this. This is a schematic diagram of a simplified version of a carbon atom. And we pick carbon because later we're going to talk about carbon-14. And we see an element, and carbon is an element, iron is an element, sulfur is an element, hydrogen and helium, these are all elements. And some of you know that brass is an alloy, aluminium is an element. So element is a pure substance where all the atoms are identical. And so they're our elements, which are the building blocks of nature. And an element is defined by the number of protons in the nucleus. So any atom that has 6 protons in the nucleus must be carbon. If it has 7 protons in the nucleus, it'll be nitrogen. If it has 8 protons in the nucleus, it'll be oxygen. If it has 1 proton in the nucleus, it'll be hydrogen. If it has 2, it'll be helium. So the number of protons in the nucleus defines the element. The neutrons are neutral, but these are the heavy particles. They're found in the center of the atom, and essentially adding these two up gives you the atomic weight of the atom, of the element rather. And then of course we have the negative charges circulating around, which are essentially weightless, very low weight, and they balance the charge of the nucleus there. So we need to remember that. An element is defined by the number of protons in the nucleus. So, an isotope is an atom with the same number of protons but different numbers of neutrons. So, So what can happen is here, get it right, John. Here we've got these. In the nucleus, we can have different numbers of neutrons. So this one here, this carbon atom, has 6 neutrons. 6 and 6 is 12. If we had 8 neutrons in the middle here, this would be carbon 14, because there would be still only 6 protons, but now there are 8 neutrons, and so it would have the heavier mass of carbon 14. And that is an isotope. Isotopes are the same element, but a different atomic weight. So carbon 12 is an isotope of carbon. Carbon 14 is an isotope of carbon. And other elements have isotopes as well. For example, chlorine has isotopes 35 and 37. Uranium has many isotopes. Uranium-238 and a number of weights similar to that. So some elements have a number of isotopes. Hydrogen has 3 isotopes. Hydrogen, and then deuterium, where there is 1 neutron extra in the nucleus, so it has an atomic weight of 2. And tritium, where it has 2 neutrons in the nucleus, has an atomic weight of 3. So an isotope is the same element, but just a different weight. And the thing is that when we have a different number, these neutrons contribute to the stability of the nucleus, and when we have a different number of neutrons, that can affect the stability of the nucleus. So often isotopes are unstable and they decay. We call them radioactive, elements like uranium and so forth. And carbon-14. So the carbon that has the extra 2 neutrons, it's heavier, but it's unstable and it decays. So that's what an isotope is. And we learned some isotopes are unstable and they decay. So carbon-14 decays to nitrogen-14. And the half-life is the time, usually in years, but it could be in seconds or microseconds, that it takes for half the amount of the element to decay away, or to decay and change into the daughter element. So that's its half-life. The life is the time for half of it to decay away. And so, let's see what I say on the next slide. Isochron age is a more accurate form of radiometric dating, where they date in the same rock different minerals, and they plot the ages on a graph, and from the slope of the graph they can calculate a more accurate age. So there are a number of assumptions that have to be made. So when an element decays, particularly a heavy element like uranium or rubidium cesium or strontium rubidium, samarium neodymium, uranium, lead. These, when they decay from one element to another element in this particular case, and that's called the daughter element. And so what we are measuring are the amounts of the original element, the amounts of the daughter element, and we can do calculations if we have measured the rate at which they decay and how much is present. We can do a calculation and work out the age of the rock. But we have to know that there weren't any daughter elements there by some other mechanism, either leaching or erosion or mixing, and that there aren't other possible radiometric processes that contribute. For example, if you're measuring a rock and there's a uranium deposit nearby that is emitting high energy particles, that may accelerate the rate of decay of something nearby or cause a different decay process. Also, we have to assume that the rate of decay has not changed over millions of years. However, there is evidence that the rate of decay is not constant. In fact, theoretically, it's not constant according to quantum theory, but the changes are fairly small. But here we have some research articles challenging the calibration of different dating and rates of decay. They've been published. So generally the fossils weren't dated directly. So you have, say, a layer of rock and the fossils are in that, and then a lava flow has erupted and flowed out over the rock. Generally, the lava has the minerals in it that are more likely to have radioactive elements in them. And so generally we date the rocks. As you can see in this case here, you've got some fossils. There you've got a lava flow that's come over and another lava flow here that's flowed over. So we can date those lava flows by dating the radioactive decay products, measuring them by chemical analysis and doing calculations. And we assume that this is older than the fossils, this is older than the fossils, this is younger than the fossils, therefore the fossils date fits in between. So that's how they calculate the age of the fossils there. So if the fossils contain carbon, of course, we can date them directly. So if they have a limestone shell, carbon is a constituent of limestone, or they have some organic material there, we can date them. But, I'll just go to that. The carbon-14 levels vary with the cosmic ray flux entering the Earth. Now let's just see this little diagram here. So essentially what happens is this. We have cosmic rays which are high energy proton particles, and protons have a positive charge. So we have these high energy positively charged particles coming from outer space. They collide with atoms in the upper atmosphere. And if you can imagine, you've got that nucleus there, and some of you might have seen where you can have a little row of ball bearings and you put one out the end and you let it go and it goes bang, and the one at the other end falls out, momentum's conserved. So the same thing can happen. One of these high energy protons can hit a nucleus and knock a neutron out. That then becomes a high energy neutron. That high energy neutron can hit a nitrogen atom. Now nitrogen was 14, 7 protons, 7 neutrons. If the high energy neutron comes in, it can knock out a proton. 7 minus 1 is now 6. What does it change to? Carbon. But now that extra neutron is there. It originally had 7 neutrons, now there's 1 extra. It has 8 neutrons plus 6 carbons, adds up to 14, but the 6 protons define it as carbon. So what's happened is we've formed carbon-14. So the carbon-14, the basic carbon is carbon-12. There's also carbon-13, but the main one is carbon-12, which is stable. Cosmic rays can produce carbon-14, which is not stable. It slowly decays 5,500 years for half the carbon-14 to decay back to nitrogen-14. What happens is one of the neutrons emits a beta particle, an electron. It's lost that negative charge. It now becomes positive. Now means there are 7 positive charges. It has now changed back to nitrogen atom. So that's how radiometric decay works. Now what happens is that nitrogen then or carbon-14 becomes part of the carbon in our atmosphere. It becomes taken in by the plants. We eat the plants, or the animals eat the plants and we eat the animals, and it becomes part of us. And it's continually turning over. But when a plant dies, or we die, we don't eat anymore. And the amount of carbon-14 then stays constant, but it is decaying. And so if we analyse something and say, it's not as high as this, but let's say there was 10% carbon-14, and we measure that there's only 5% carbon-14, then we would say that is 2,500 years old, or half the 5,000 half-life, okay? So that's what happens. We measure the amount of carbon-14 that is levelled. So if we measure only a quarter of the amount there, then it must, well, if we measure half the amount of the standard level in the atmosphere, then we know it's 5,500 years old. If we measure a quarter of the amount, it would be 10,000 years. If we measured an eighth of the amount, it would be 15,000 years. If we measured a 16th of the amount, it would be 20,000 years. Get the concept? So depending on the amount of carbon-14 there, so we know the basic level in the atmosphere in parts per million. So they're very low levels that we measure. And so that is how carbon-14 dating works. And yeah, that's just another schematic diagram. So the level, and it's showing that the level as it gets older and older. But once we get to an age of, say, 100,000 years, there would be no detectable carbon left. So if we don't find any carbon-14, then it could be older than 100,000 years. But if we find carbon-14, it must be way less than 100,000 years. So that's very significant. If we find it, it definitely proves a young age. Because if it's more than 100,000 years, it can't be there. It's all decayed away. It's all gone. That's fine. So if we find some, it must be young. Now that's very significant, important. So, how's the age of the Earth measured? They find uranium isotope there, has a half-life of 4.5 billion years, and therefore the maximum age is about 10 half-lives, so 45 billion years. They don't find any samarium-146, which half-life 0.1 billion years, and therefore they assume a minimum age is 1 billion years. So they do this for a number of isotopes, and they come up with an age of about 4.5 billion years. But as you can see, it's based on a whole lot of assumptions. How do we know how much uranium was there? How do we know that there was samarium there in the first place, samarium-146? There might not have been. So these are, these are all assumptions, and we need to recognise that. They're assumptions. They're totally unproven. So that is a calculated age based on unproven assumptions, and we can't ever prove it. So we need to actually also realise that radiometric dating has never actually been proved to give the actual age of a rock. Let me have a look at these things. For example, we can date rocks that are only 60 years old and we still get millions of years old. So this is very interesting. Let's have a look then at what we've got here. The continents are typically dated as about 3,000 million years old by radiometric dating. But when we study erosion rates, the continents would erode away in less than 10 million years. Now, we can go out and measure erosion rates now. We can see it happening. We have good data on this. We have data on this from around the world, from different continents that agrees. We have the sediments in the bottom of the ocean. We know roughly how much is there as well. It all points to an age less than 10,000 years. Matter of fact, we know that there were lush forests in the past. That's where all these coal seams have formed from, lush vegetation. So there must have been higher rainfall in the past. Higher rainfall in the past, faster erosion rates. So we know that the continents would have eroded away, and yet they're dated at thousands of millions of years. And we've got like the Grand Canyon rocks date back to like 600 million years or more. But the whole continent of America would have eroded away in less than 10 million years. So you can't have it both ways. Which method has uncertainty? The radiometric dating, because it's based on unproven assumptions. Erosion rates we can measure. And if we have catastrophic events, they're going to be even faster. And so we're on very good ground here. There's a total inconsistency there. And 10 million years is nowhere near enough for the evolutionists. And that's really good data. It's consistent data. We can go out and measure it today. And again, that's where I showed you. They're the different millions of years down to the Cambrian, about 600 million years. And geologic timescale and the typical sort of animals that they put for there. But let's have a look at some dating, okay? Now, traditionally they date fossils according to the dates signed over the years, essentially using Lyell's chronology and so forth, that are based on looking at these layers of sediment and calculating how long, estimating how long they would take to form. That was how the dating of the fossils was set up, with millions of years, based on the thickness of these layers of sediments. But we've already shown they must have been laid down under catastrophic conditions. They have no erosion rates in between, so their calculations have got to be out. But that's what they use. And then they back them up with radiometric dating. So let's have a look at some examples. We've got a Pleistocene lava that was dated 1.6 million years from the fossils that were found nearby. But when they dated it, rubidium strontium, it was 773 million years. So a vastly different age by radiometric dating. 1.6 million years from the fossil standard method, 773 million using strontium dating. Again, another example there was the Pliocene to Holocene rock, less than 5.3 million years, but rubidium strontium ages go 570 to 870 million years. So how old is the rock? 570 million years? 870 million years? Another example, a Pliocene lava, 5 to 9 million years. Potassium argon, 31 to 39 million years. 5 to 9 million years by potassium argon dating, 31 to 39 million years. So how old is the rock? Which value are you going to choose? The potassium argon data or the rubidium strontium data? Well, what they usually choose is the result here that fits closest to the fossil age. That's the standard method. That's Copeland Dam in Queensland, I think. Oh, Somerset Dam, sorry. 1997, isochron dating. So not that old. Isochron, the most accurate method of radiometric dating, analysing a number of different minerals in the same rock. It's from an intrusion in the dam wall or in the side of the material where the dam is. Conventional fossil age, 220 million years. Potassium argon age, 174 million years. Rubidium strontium age, 393 million years. Samarium neodymium age, 259 million years. Lead isochron age, 1,500 million years. That's dating the same rock, recent data, all isochron dating. That's averaging out many results by 3 different methods. How old is the rock? How old is the rock? That's published data, scientific data. How old is the rock? They don't tell you about that in the textbooks, do they? So we got Grand Canyon rocks, some of the data from there, the Cardenas basalt. Conventional age, just over 1,000 million years. Potassium argon age, again, isochron dating. Many data points averaged out, 516 million years. Rubidium strontium, 1,000. So that'd be close to the conventional age. So they'd publish that data. Samarium neodymium, 1,500 years. So what happens is, and there's your lead isochron. So a range of ages. But if the conventional age, fitting in with the column, is 1,100 years, they'll omit the other dating results and they will publish the rubidium strontium age. And that's the conventional, what happens in the literature. But again, how old is it? Is it 1,000 million years? Is it 1,500 million years? Another one, Brahma rocks, base of the Grand Canyon. Rubidium strontium age, 1,240 million years. Samarium neodymium, 1655. Lead, 1883. Let's have a look at some recent ones. Mount Noahoe in New Zealand, erupted in the early 1950s. So these samples were analysed at the Research School of Earth Sciences, Australian National University, 1998 to 2001. You can look the data up on the internet. You can look up the scientists that did the analyses. You could email him, ring him up. Rubidium strontium isotope age. So this is for rocks, 1954, 1949. Analysed 1998 to 2008. Average 50 years old. Rubidium strontium isochron age, 133 million years. Samarium neodymium isochron age, 197 million years. Lead isochron age, 3,900 million years. If rocks that are only 50 years old give radiometric dating of millions of years old, how old is any rock? How old is any rock? If you get a value for a rock of 300 million years, 450 million years, how old is it? It could be only 50 years old. It may be only 200 years old. It may be only 1,000 years old. See the point? You've got major problems with radiometric dating. And there are many examples in the literature. We talked about that. There's other data on the thickness of the sediments of the ocean floor would deposit in less than 30 million years. All the volcanic deposits on the Earth's surface would form in well under 34 million years. And so, again, the continents cannot be as old as the radiometric dates. We're getting radiometric dates of hundreds of millions of years, thousands of millions of years, and yet we know from sedimentary data, we know from volcanic deposition data, can't be anywhere near that old. We got major inconsistencies in the scientific data. It's not correlating. We've got this book on genetic entropy by, what happened there? By Stanford, University of Stanford, by John Sanford at University of Stanford, who's a geneticist there. And what he's saying is that DNA of living things is steadily accumulating errors. So we can calculate how long it would take before there would be so many errors in the DNA that the plant or animal or bacteria would no longer survive. So if we look at mitochondrial DNA, which supplies the energy source in many living things, we can work back as to how long it could be before there'd be enough accumulations that it wouldn't work anymore. And the maximum is 100,000 years. Or it could be as less as 10,000 years because we don't know exactly how much the process, how many mutations the process can accommodate before it fails completely. But when we look, so what we look at this is, we're saying that when we look at life, the rate at which we can measure, and these papers are published, they've got a lot of data now on the rate of accumulation of mutations. Data's published in journals like Nature and this sort of thing. This is not fringe biology. This is mainstream biology. All the DNA on our planet is accumulating mutations at the rate which is not causing evolution, but is causing the malfunction of the organism. And those, as we look at these calculations, give an answer of 100,000 years max for life on our planet. 100,000 years maximum. But there's more. So here we have a guy cutting up a bone from a dinosaur that is dug up. As we know, since the early 2000s, they've been discovering and extracting soft tissue from dinosaur fossils. And this was a major breakthrough. When Mary Schweitzer first published this result in the late 1990s, she was just absolutely rubbished. She's published a lot of data since then, and then 2 years ago, I think I've got the paper coming up. It's from Montana University, by the way, MT. They had a group from a number of universities went out. And actually, I'm getting a bit ahead of myself. I'll come to that. It's really exciting stuff. Whoop, whoop, whoop. So they've extracted soft tissue from the dinosaur remains. So soft tissues and blood components and other proteins have been found in dinosaur fossils dated up to 120 million years old. In 2009, a freshly dug from under 7 metres of rock dinosaur leg bone yielded collagen, proteins, bone cells, parts of DNA independently verified by researchers from 3 universities, including Harvard University. There was so much dispute over this because that defies. These are polymer molecules that break down over time. They can't be millions of years old. But there they were, fresh samples. They could see them under the microscope. They could analyse them. It was unbelievable. It totally defied their timescales. And so, as I said, 3 mainstream secular universities sent teams out. They took an excavator out. They went to an area that definitely hadn't been tampered with, so nobody was planting anything in there. They dug down 7 metres fairway, 20-odd feet, found in a known dinosaur bed area, and dug up the fresh samples and analysed them there. Published in Science, okay, the American version equivalent of Nature. So Nature and Science are the two top science journals in the world. Another paper, molecular analysis of bone cells support the presence of indigenous molecules from the original animal. Published in 2013. Very interesting stuff coming out. University of Lund, Sweden. It's interesting in a mosasaur lizard. And I remember I was in a hotel once, put the TV on, and it had a documentary on them actually excavating this animal, found quite up towards the North Pole on one of the islands there under the ice, and there was only like a 10-day period where they could work, otherwise everything was frozen. They sort of shipped an excavator up there, and it was an amazing job to get it out. But this doesn't appear in the abstract of the article, but when you read down through their data, you find that 5 milligram of carbon was extracted. 3 milligram was used in carbon-14 analysis and gave an age of 24,600 years. Conventionally dated, 70 million years. Pretty cool. Now, when they've dated, there was a paper published last year, I think, at the big Geosciences conference that was held in Malaysia. And scientists from Europe had collected soft tissue samples from dinosaur and other lizard samples from around the world and had them carbon-14 dated, and they all came out at around this sort of age, around 25,000 years. So nothing like the... Where have we gone here? Nothing like the millions of years that these dinosaurs are supposed to have died out and when their fossils were. And also, we know from experiments in the laboratory, again, reference to the scientific literature, collagen has a maximum stability calculated of 130,000 years. So when we look at the best data that we have, it's all pointing that these fossils are very young, not the hundreds of millions of years old that the textbooks are claiming and the evolutionary time scales are claiming. When we look at the best evidence, we can go out and measure now. These are guys doing the measurements now, digging the dinosaurs up now, using the best mass spectrometers to measure carbon-14 and so forth, and analysing, observing proteins and other molecules that would normally break down, measuring carbon ages and getting young ages for these things. Only tens of thousands of years. But there's more. We've talked about that. Coal is typically 30 million years or more older. Typically 30 to 300 million years, a typical range for coal samples. And at the Pennsylvania State University have their library of their standard coal samples where they've gone to different coal beds and very carefully removed very large chunks of coal and stored them under argon. And these are coal reference samples that are used for research. Recently, these were analysed for carbon-14. Now, up till recently, nobody looked for carbon-14 in coal. Why? Well, it wouldn't be there, would it? After 100,000 years, there'd be no detectable carbon-14. So why analyse coal samples? Nobody did it. So they decided to do it. And they found some very interesting results. Right? So there were some coal samples that were analysed by one of the latest technologies that were available. And the 10 coal samples that they used all gave ages between 40 to 60,000 years. And yet they were 40 million to 300 million years by conventional dating. But carbon-14, we know, is an absolute method because after, as we said, 100,000 years, there's going to be no detectable carbon-14 there. So the fact that they measured carbon-14 mean that those ages are much less. Not enough time for evolution, no way. So their whole dating is thrown into disarray. Now, I'll talk about the Earth's magnetic field effects I'll talk about them now, probably. Let me go on to diamonds, then I'll come back to that. Diamonds. So these are pure carbon, formed under very high temperatures and pressure, supposedly formed when the continents formed, several billion years old are the dates for diamonds. Absolutely no carbon-14 should be there. But diamonds were analysed, all contained measurable carbon-14 and gave an average age of 55,000 years. A subsequent study by the University of California, using one of the most accurate mass spectrometers anywhere in a research university, the carbon cycle atomic mass spectrometer, accelerated mass spectrometer, gave carbon-14 ages ranging from 64,000 to 80,000 years. And they could go that little bit further because they could go that much lower in accuracy. That's University of California, major research university there. So, those diamonds in the continents from the carbon-14 dating are only thousands of years old, tens of thousands of years old, not millions of years old. This is data that was published quite recently. It was only done a couple of years ago. We're not looking at old data. We're not looking at old equipment. We're using the best technology now. And this study was done at the University of California because they saw these other published results and science was saying, hey, what's going on? And so they did this very accurate, high-precision analysis of the diamonds, and they said, there's something weird going on here. We just got to think up a theory to account for this, so it's still millions of years old. But that's the data. This is what's telling scientists. And so there are a number of sites. But let's go back to what we were talking about here, the Earth's magnetic fields effects. Remember I said that the nitrogen-14 was formed, in effect, by cosmic rays. What are the cosmic rays? High-energy protons. What do protons carry? They carry a positive charge. What does the Earth have? It has a magnetic field. This magnetic field repels the positive charges. It there in part protects us and reduces the amount of cosmic rays that hit the Earth so it doesn't wipe out life. Interesting. The Earth's magnetic field has been decaying. It's decayed 6% since 1900. In other words, the Earth's magnetic field in the past was much stronger. If the Earth's magnetic field in the past was much stronger, it repelled more cosmic rays, therefore lower levels of carbon-14 would be formed, which would give you artificially long ages. Get that? If you have a lower level of carbon-14, because the lower the level, remember it's compared to today's level? When they do their calculations, they only compare it to today's level. We don't know what the level was in the past. We can estimate it, though, by looking at the rate of change that the Earth's magnetic field has decayed, and we can extrapolate back and estimate what the Earth's magnetic field may have been 4,000 years ago. 4,500 years ago, the time of the flood. And when we do those corrections, at that time it means that the starting amount of carbon-14 was much lower, and compare that to the measured value, we actually get ages for these coal and diamond samples of around 5,000 years. So when we do the corrections, it corrects back to the biblical timeline dates. Don't be afraid of 25, 40, 50,000 years for carbon dating, because when we correct for the cosmic wave effect, it brings it back to 4,000, 5,000, 6,000 years. That's incredible. We have excellent data backing the creation young Earth model, both from the carbon-14 dates of coal, carbon-14 dates of diamond, carbon-14 dates for the fossils. And maybe the diamonds were created before the flood, and that's why they give those slightly older ages of 60 to 80,000, which when calculated back give an age around about 6,000 years. This is what we can measure now. It's reproducible. We can go out. The best data that we have points to the biblical age for the age of the Earth. being told that. But there's more. Well, we've already talked about that. That was George Dodson, the South Australian government astronomer. We've got the angle of the tilt of the Earth there. We've got the measurements. I already talked about that last year. That's his data. You can look up his data on the internet. Those of you who have done some applied maths or pure maths even, you can look up his data. Just Google Dodwell manuscript. His family has put the data up on the internet. Bernard Bandstand, an Adventist anaesthetologist professor at Loma Linda, was a friend of the family, and he has been editing the work and writing it up because Dodson died before he finished writing his book. But all his data is there, but he was writing it up. He believed that it coincided with the flood. As I said, my theory is that it actually coincides with the period after the flood when the mountain ranges were put up. But you can go, that's the Newcomb's formula prediction. It's the deviations from Newcomb's formula with the measurements on there from, and you can look up his data, but what he's plotted there is from different monuments. That one there is the Karnak monument in the Valley of the Kings. And again, that date is disputed by about 400 years. There's uncertainty of around that date, depending on the particular theory. And that's the problem with some of these older dates. But irrespective of that, the errors there, you've got a curve that has a major event roughly 2,500 BC. So, again, look up his data on the internet. You can check it for yourself. So we're not working with anything that's fringy and dark speech or anything like that. We're working with the real things. And people say, well, hang on, what about the Big Bang Theory? And really needs another session, but I'll just quickly run through it here. We hear a lot about the Big Bang Theory as well. Did you know that astronomers really have no established theory that can explain the origin of the universe, the origin of planets even? You know, God has put, the way God has set it up is to confound the wise, because the angular spin of the sun is different to the angle of the plane of the planet, so it can't explain that it was the same, you know, a whole lot of gas sort of cooling down. It just doesn't work. And you hear these things about the dust clouds coalesced and formed the different stars and so forth. It doesn't work that way. There's so much empty space. The clouds of matter just separate. They don't come together. You've got to have particles to set up a gravitational field to start with to coalesce from, just like when you're growing crystals. If you have a really pure solution, you won't grow crystals. You've got to have some imperfection there to start the crystal growth off. You can have supersaturation, and then you introduce a seed, some impurity in there, and boom, you can just about set solid. And that's the same problem. You need matter to start the condensation. But where did the first matter come from? You can't. They haven't got a model yet that works. The Big Bang Theory is full of contrived assumptions. You know, sometimes people say, hey John, fourth day the stars are created. They're billions of light years away, some of them. How come we could see them? You know, we've got a major problem there. Or if God created the light and they weren't really there, then, you know, God isn't being honest. But hang on. Inflation theory says that the universe and space, when it expanded faster than the speed of light. The Big Bang Theory have to have really rapid expansion to start with as well. So if they can have it, surely we can have it too, eh? Isn't that fair? Don't you think? If they can have expansions and laws of physics exceeding the speed of light, can't we have that too? Can't God create things so that the light travel was very fast, almost instantaneous? It's got to be fair. But they have major problems. They're going to have dark energy. Where did the energy come from that started everything off? Creation? What creation? Try God? The Big Bang Theory is just a creation myth dressed up in maths. That's all it is. Dark matter. Why do they have dark matter? Why? Because the law of Bayron number, which we can measure, says that if you create matter from energy, you create the equal amount of matter and antimatter. When we look out in the universe, it's 90-something% matter or thereabouts. Where's all the antimatter? So they have to adjust all their parameters and maths to make this happen, so they have to have dark matter. Also, many Christians think, well, maybe creation, the Big Bang, expanding into space. That's not the Big Bang theory. The Big Bang theory is space expanding in a fourth dimension. Why? Because it's very interesting. The location of Earth is in a very unique place in terms of us observing the universe. It's almost as if we're near the centre of the universe. We're out on a bit of a limb on the Milky Way so that we're protected from all the nasty radiation and protected with a couple of giant planets out there from nasty objects hitting us. We're very uniquely set up. And they didn't want to have a space system where there was a centre or where we were near the centre. And so they developed what they call the cosmological principle. And it's like, and essentially it's like this. That what that means is there's no centre to the universe. And it operates like this. I'm going to have to put this, or maybe I don't put it down. Imagine a balloon, right? So you imagine a balloon. And on this balloon you draw little circles. You do that? You do that in your mind? Draw little circles on the balloon, right? And now you blow the balloon up. As the balloon gets bigger, those little circles move away from one another, don't they? Right? So they're expanding. They're on the surface of that balloon and they're moving away from one another. So they're expanding. Where's the centre of the surface of the balloon? The surface of the balloon has no centre, does it? So if you have space expanding in a fourth dimension, there's no centre to space. Get it? So that's why they have... The Big Bang Theory isn't about matter expanding in an empty universe. It's about space and matter expanding in a fourth dimension, which, by the way, has never been proved, can't be detected. So all of these things are just contrived. Inflation theory, which says that the laws of physics didn't hold initially, and we think up artificial laws. How can you prove that? They say you can't teach creationism in schools because you can't prove it. You can't set up an experiment that proves creation. Can you set up an experiment that proves inflation theory, Big Bang? I don't think so. See, it's all contrived. It's contrived to fit model. And then they go out and they say, well, we'll set up this model, we'll make observations. All the predicted observations of insignificance, anyway, of the Big Bang Theory have not been verified. They don't fit. When we go out, we do a calculation, such and such should happen, we go out to look for it, it hasn't happened. And I guess I list these examples up until a recent time in my book there. So in terms of evidence to verify the Big Bang Theory, it's lacking. That's why they're exploring all sorts of other things, like string theory. But string theory doesn't just require a fourth dimension, it requires a minimum of 12 dimensions. We're getting into really theoretical maths here, really fascinating stuff. What it is, it's playing games to try and avoid the reality that God created our universe. That's the best scenario that we have. It fits the data the best. There are major problems with the Big Bang Theory. And why do they have to have things like inflation theory? People criticise about sunlight. Well, you've got the horizon effect. The background microwave radiation is pretty well uniform around us. But how can it come to equilibrium? There's not enough time, unless the radiation is travelling much faster than the speed of light. So scientists can't explain the universe. But what about the origin of the mind? And we talked about that in church, didn't we? Moving our little finger. What our mind? What is the mind? The brain is chemistry. Ben Carson can cut pieces out of the brain and we still live. It's molecules, it's chemistry. It obeys the laws of chemistry and physics. But your mind, your thoughts, don't have mass, they don't have volume, and yet they can interact with the physical world. And this is something that scientists still can't explain and get their hand around. And that's where, this is the area some of the top philosophers in the world, philosophers of science, are working on. Thomas Nagel, New York University professor, argues that the mind proves that Darwinian evolution must be false. His book is Mind and the Cosmos. You can see the reviews on Amazon. He's, again, really stirred up the evolutionists. And essentially what he says is there must be some property in the universe that generates intelligent type design, that generates the mind. And that's why he says the mind and the cosmos. Essentially saying all the best data that we have points to the existence of God. But he's an atheist. He doesn't want to have that. He wants to have some materialistic explanation. When you read his book, he summarises all the data, and essentially he's saying we've got massive evidence for the existence of God. And so this is where things are up to. When we look at the explanation that best fits the data, a caring, intervening, awesome mind, God created our amazing diversity. Some of the students have said to me, okay, I think it came up yesterday, you know, if God created these things, why do we have mutations? Why are there problems? Why are there big biting animals? And little biting ones for that matter. You know, when during the atheist debate that I had with the Sydney atheists, you know, one of the guys said, well, God, what about all these terrible, you know, little worms that get into you and eat you from the inside out, and all this sort of thing. And I think that the Bible too has an answer for that. If we look and read through the whole Bible, in my view, this is my understanding of it, that we had a creator of this world. And there are definitely other space-time systems. There's a spiritual world. There's evidence for that too, and there's been scientific studies into this. Princeton University, Professor Thomas Jahn, his book, The Margins of Reality. Fascinating book. Another book on dreams by a professor from the University of Virginia, who looked at people who had dreams that foretold in detail the future ahead of time. Another fascinating subject that we could look at. These are outside materialism. So there's a lot of evidence for the spiritual realm, but I think it's outside our space-time system. There can be lots of other space-time systems. John Wheeler got his PhD in the early 50s for coming up with the multi-universe theory. But if we look at what the Bible account says, we had a creator here. And there was another being that came that was jealous of that creation. And he came and he told the first lie. So Adam and Eve, the first people, were told, don't eat of this tree. If you do, you're going to know about evil. And the consequences are going to be that you will have to die. Because God can't have the continuation of evil in the universe. Now, evil had been threatened there. There was a war starting. There was a conflict between these super beings and the other beings associated with them. Maybe we can call them the angels. And so Adam and Eve were told the first lie. No, if you eat of that tree, you won't die. And God was now trapped when Eve believed the lie. She disbelieved God, which meant that God was a liar. And God was now in a tricky position. He loved his creation, but now they were sold over to this opposing power that was hell-bent on destroying God or Jesus' beautiful creation. Here was the enemy, here was Satan. There was a conflict between the two. And Satan was bent on destroying and corrupting everything that Jesus had made. This is my understanding of it. And that God, Jesus, loved the humanity, loved Adam and Eve. He didn't want them to die. But if he didn't let them die eternally, then he would be proved a liar. And Satan's point would have been made. God can't be trusted. And that's why God, who loved us so much, he said, I'm going to prove that I'm not a liar, but the wages of sin are still death. The wages of evil are still death. But I'm going to die in your place. pretty bad. And I think that explains beautifully the origin of sin and evil that we see in the world. We see, you know, like that guy who's standing in front guarding a statue and somebody comes up and kills him in cold blood. It's evil. We can identify evil things. We see many evil things that are happening. And then we see the beauty and the good things, the kindness that's happening. We see there's a war going on. And the way I see it is that the image of God is being destroyed in mankind. Knowledge of God is being destroyed. I see the theory of evolution as part of this. It's a lie to separate us from God. That's my view. It's not a scientific view. That's my personal view. And that's why I'm so passionate, because it's another lie. Satan, I believe, is the father of lies. And that's why it's so important to have good data when we're arguing this. But I think that's the situation. We have this loving God that created our planet. And that's why he died for us. Jesus died for us. So that we are now in the position that God can save us. He can not let us die. Because Satan's claim against him has been disproved now. And he is now free to give people. And that's why it's a choice. But God only wants people that choose him, that want to live in his type of kingdom. So that's as I understand the gospel. That's how I'm so passionate in this area. But thanks for coming along. I think for those of us who believe in the Bible, we're in a very, very strong position on the basis of the evidence that we can know and measure today. There's an effort out there to suppress that evidence, to ridicule it, to say that it's lies. And I've published in this area, and people have written in and said, Ashton is using made-up data. Ashton is using debunked data. Well, my book is out there. That's what I believe. The evidence is summarised in that. I put it up on the internet under Facebook Evolution Impossible. See and read the papers that I refer to, the sources that I use. Judge for yourself. And that's the basis. We need to make our decisions on the basis of evidence and data. That's what God does for us. God sent his Son to show that's the evidence that God is love. God is not someone to be feared. He had to do some fearsome things at times because we were behaving like 2-year-olds and doing stupid things to each other. Well, you know, think of pagan history, how they killed each other all the time. In fact, we still do it with modern weapons, I suppose. Breaking down the family. Doing horrible things to one another. God had to somehow try and wake us up and turn us back to him. Anyway, I'm preaching now. Thanks for listening and for putting up with me. I'm happy to answer some questions. Well, now.
Thanks, John. There we go, we're on. Thank you very much, John. A couple of questions. There's three questions, but the last one's a quick one. Okay, here we go. If everything...
Can we do one at a time? Because I might not remember.
Yeah, one of them. If everything was buried at the flood, why do we not see humans fossilised with trilobites? And there's an explanation comment. Hydrological shifting would place the bigger, heavier organisms at the bottom.
Okay, I don't know.
Yeah?
But, I mean, let's face it. In a flood, humans are pretty intelligent, so maybe they did things for a while and got out of it. I don't know.
Good, honest answer. Thank you, John. All right. The next question. Last night you noted that E.O. Wilson calculates the current rate of extinction at 0.25% a year. Do you, I think it means, do you think this number could change in the future or could have changed in the past?
Oh yes, certainly. It's going to depend on a lot of facets. I think it is increasing, but that's what we measure at the present time. The rate of extinction is pretty high, and we know historically a lot of animals become extinct.
One question: do you know what that number is based on?
I can't recall, but it would be based on the number of, estimated on the number of species that we know at the present time, and reports of the number of species that we're losing. So, for example, when I was in the Flinders Ranges the other year, they had a list up of 6 mammals that had become extinct since white settlers moved into that area. So I guess it's based on that sort of area of destruction of habitats and this sort of thing. He's the expert in that area. I just have to rely on this sort of data. But he is a professor at Harvard. I presume he's done his homework well.
The last question I have here is, may I have a cookie?
Is that a computer program then?
And yes, you may have a cookie if there's anything left on the counter there. Should we take any questions from the floor, or do you want to do that informally?
Yeah, look, it's very late and I'm just about falling asleep as well. But no, happy to answer questions if you want to come up and ask questions.
Sure. All right. Well, yeah, hang around.
Anyway,
Yeah.
all the best.
Thank you, everyone. I think Joel's just going to do one last